Okay, now we come to resistive network analysis, right? Okay. What mean by analysis is just mean that we determine some value, unknown value, right, to calculate for unknown variable. Okay, and uh, mostly I will talk the content in the chapter 3 of the reference books. Okay, yeah. And you can read for more information in this book, and also for your practice also, right? The practice. And there are some answer to some problem, the solution, right? The solution of your homework is here, right? Just for uh, some problem, not all problem have solution. Okay. Okay. We start with the node voltage method, right? I will talk about node voltage method. What is node voltage method? And mesh current method. Node voltage method we solve by using KCL for the circuit, and mesh current we solve by using KVL applied to the circuit. Okay. And the node and mesh analysis with control source. Maybe I just skip this. I remove this content for you, right? But the student, those who are interested in further study, you can come to discuss. If you need to learn, right, you can come to see me. I think it's okay. It's not uh, required. You just learn some basics, right? And we go to some other part for application. And I will talk about superposition. Okay, this is fine. One for equivalent circuit. Okay, and this is Thevenin and Norton equivalent circuit. Thevenin, Thevenin, so Thevenin and Norton equivalent circuit. Right. This is the main topic that I will talk. Okay. So let's start with node voltage analysis. When we face with some more complex circuit that is difficult to some to calculate for the total resistance, right? For example, total resistance, you merge the resistance by series and parallel resistance, right? Uh, but if you face some circuit that difficult, for example, like this, it's just now difficult to solve by finding out what is total resistance, right? It's not possible to do. We need to use this type of analysis, right? You have learned some in physics, no? No, never. Cannot remember. You know, that you learn or not. You have learned or not, right? You cannot remember. Okay. In physics, you learn some circuit. Okay, but you cannot remember what you learn. Okay. Okay. I think some nodal analysis and mesh analysis is there or not? I'm not sure. Okay. Anyway, I will talk about that. Ah, okay. For nodal analysis or node voltage analysis method, right? Uh, what we do, right? Step by step. Okay, just step by step, not difficult. Okay, especially for resistive circuit with uh, DC. Okay, DC source, right? It's not difficult. First, we select one reference node. Okay, one reference node. We select a reference node. For example, in this circuit, we select node C as reference. Usually, it's the ground, and this node is taken at 0 voltage. Then, other voltage of other node, the voltage of other node will respect to this voltage, right? Here, like this. Okay, we select reference node. Okay, usually we select the node that most common. This means that most element connect to it, right? Most of the element tie to it, connect to this node. Have many branch, right? The node that have many branch, we select that node. That will make us easy to calculate. Okay. Then other node will refer to this node, right? We The voltage of node A is VA respect to this voltage. Okay. Then one node take as reference will remain n minus one node, right? If we have n node, we take one reference, will remain n minus one voltage to find out, right? To find out n minus one voltage to find. So we reduce the variable, right? Okay. Each of m voltage source in the circuit is associated with the dependent variable. Okay. If the node is not connected to voltage source, then its voltage is treated as independent variable, right? So if one node, for example, if we have voltage source like this, like node J, 4 like this. The voltage of node J will be equal to this voltage, right? We don't need to calculate, right? We know Vj is this voltage if it's connected to voltage source, right? That we don't need to calculate Vj. We know this voltage already. But for the node that not connect to the voltage source, right? Node A and node B here. So we take as variable, okay? Variable. Then we apply KCL. Take KCL at this node. Take KCL at this node. Okay. What mean by KCL is the summation of the current into the node or flowing out the node is 0, right? KCL is sigma I equal to 0 for that node. Okay. Then we solve for n minus 1 minus m mean voltage source, right? Unknown. We have n minus 1 minus m unknown. Right? For example, this circuit, right? We have Is here. I1. What is I1? What is I1? In the term of VA. I1 is VA minus VC, right? This means minus 0, right? Divided by R1, right? I1 is VA, the voltage across R1 divided by R1, right? I1 is VA minus VC. VC is 0 divided by R1. This is okay for all of you. Before I go further, it's okay? Okay, no? Then what is I2? I2 will be VA minus VB divided by R2, right? The voltage across R. right? Divided by the resistance. This is Ohm law, right? Ohm law. And what is I3 here? I3 is VB minus 0 divided by R what? R3, right? Okay. Then we can write down the current, right? In each branch. The current, we write current in voltage form. Represent current in the voltage form. Because we know R1, we know R2, we know R3. Okay, we know the resistance. Okay, then for example, KCL at node A is IS minus I1 minus I2 equal to 0, right? KCL as node A. IS minus I1 minus I2 equal to 0, right? The summation of the current is 0, right? KCL equal to I1 plus I2, right? IS equal to I1 plus I2, right? Right? Then we can write down IS minus IS is known. We know this value, right? E minus what is I1? VA divided by R1 minus what is I2? VA minus VB divided by R2 equal to 0. Okay. Yeah. Then KCL for node KCL for node B. What is KCL for node B? It means I2 minus I3 is 0, right? I2 minus I3 is 0, right? And what is I2? I2 is VA minus VB divided by R2, right? And what is I3? I3 is minus VB divided by R3 is 0. Then I interested in this equation and this equation. Then we know IS, we know R1, we know R2, we know R2, we know R3. Okay. Then what is unknown? What are unknown? VA, we don't know VA. We don't know VB. Yeah, we don't know VA. We don't know VA. We don't know VB. Right? And we don't know VA. We don't know VB. We don't know VB. How many unknown? Two. How many equation? Two. Then can we solve for VA and VB? Then we can solve for VA and VB, right? Okay. So with this methodology, we can solve for VA and VB by solving two equations, two unknown, right? So first, we need to formulate the equation first, okay? And the method is not complicated, right? We just follow the step. We follow the step. Okay, I will show you an example. Okay, let's see this circuit. It looks quite complicated, right? Quite complicated circuit. More It's not so complicated, right? How to solve this circuit? Okay, we know that with this circuit, we know that I1 is 10 milliampere. Here, this is 10 milliamp. It's the current source. I2 is 50. This is 50 milliamp. It's the current source, right? In this direction. This is in this direction, right? R1 1 kO. R2 2 kO. R3 10 kO, right? R4 2 kO. Here. We follow the step, right? Focus on the methodology. The reference ground node is chosen here, right? We choose ground node first. Then we remain two nodes, right? Node 1, node 1 here, and node 2 here, right? Node 1 and node 2. Node 1 is here. Node 2 is here, right? This is the current flow to the node. The summation of this current, this current, this current, this current would be 0, right? KCL. Similarly, for node 2, this current, this current, this current, this current sum together is 0, right? We take KCL, right? And with this method, we define V1 and V2, right? Then we can formulate the equation. No solution, right? We need to solve it by ourselves. So we need to solve by ourselves, right? No solution here, right? Okay. Okay, first we start formulate the equation. Okay, how about node 1? KCL node 1. I1, I1, right? Minus, right? Minus. Which one first? This one first. Okay. V1, V1 divided by R1, right? V1 divided by R1, right? V1 is unknown. V1 is unknown. Next is V1 minus V2, right? Minus V1 minus V2 divided by R2, right? R2. Not very difficult, but you need to just keep focus on the step. R2, right? Next, minus this current is V1 minus V2 divided by R3 is equal to 0. Okay? Right? Then we can substitute I1 10 milliamp, R2 R1 1 kO, R2 2 kO. Like this, right? You can substitute. Maybe I substitute later. I will take node 2 first. KCL at node 2. The current flow in is positive. It's okay. The current flow here is V1. This is V2. V1 minus V2. V1 minus V2 divided by R3, right? Plus V1 minus V2 divided by R2, right? Minus V2 divided by R4 minus I2 is 0, right? Then we just substitute the value, right? What is I1? It's 10 milliampere. 10 milli, right? 10 milliamp minus V1 1K, right? 1 KO minus V1 minus V2 divided by R2 is 2K minus V1 minus V2 divided by 10KO, right? 10K equal to 0, right? This is this equation, and the second equation is V1 minus V2 divided by R3, right? R3 is 2K plus V1 minus V2 divided by R2 is R3 is 10 KO. R2 is 2KO, right? To avoid confusing, and minus V2 divided by R4. R3, R4 is 2KO, right? And then minus the current I2, which is 50 multiplied minus 3 equal to 0. Okay. Then finally we have two equations, two unknown, right? Can you rearrange the equation and solve for V1 and V2? Just rearrange the equation, right? And solve for V1 and V2 after this. Okay? So I hope that you can do it. I hope that you can do it. And check with this solution. Okay? Just rearrange the equation. Right? It's a good practice, right? Because you will face this problem also very high popularity in your exam, right? It's not very difficult, right? But just follow the step, keep on the step. It will uh, it will be good if you do practice. Otherwise, when you see the circuit, you don't know what to do. Okay, I just give you a circuit. You see a circuit, and you just don't know what to do. Okay, that will happen to the student who are not practice. If you see an example, oh, okay, it's not difficult. If you follow my calculation, oh, okay, it's not difficult. But you never do by yourself. Okay, once you face the circuit, you just don't know what to do. Okay, do you believe that? If you don't believe, try it. Try, do not practice. Okay, maybe you win. Maybe you win. Some of my friends can do that without practice. He just follow the teacher, professor, and then we don't need to study anymore. Very clever, but only few of my friends, really few. Okay, I agree that some people can do that, but I think most of the people need practice. Okay, me too. Okay, I practice a lot when I was student. Okay, it's it's nothing to lose if you just spend your time to study, right? Nothing to lose. Nothing. Okay, let's see some more example on this. This example is to write down to write the nodal equation and solve for the node voltage, right? Yeah, node voltage. To write the nodal equation. So we face this circuit. I just show you this circuit. What to do first? Select the reference node. Come to our first slide. Select the reference node. Right? Like this. Just follow the step. Yeah. This is a reference node. Okay. Usually we select the the most common node. This is reference. Now we remain two nodes, right? VA and VB, right? Then we have this. Okay, then we define the current. We can define the current flow in, flow out, the node flow to node A to B or B to A as well. Any. Okay. And this is the known value, right? We know this value. We know this value. Okay. We know this value. Okay. Okay. Analysis. Then follow the step, right? And the methodology. And the reference curve is chosen, and then in this. Okay. We take KCL here, KCL here. For node analysis, we take KCL. And we write out the current in the voltage form, right? Node A, KCL node A is IA, right? IA minus I1 minus I2, right? I1, what is I1? Minus I1 will be VA divided by R1. And I2 is VA minus VB divided by R2. Just this. Just like this, right? Then the KCL at node B. KCL at node B. This will be I2. I2 is VA minus VB divided by R2, right? Plus IB, right? Plus IB. Minus I3 minus I4. Minus I3 is minus VB divided by R3, right? Minus VB divided by R4, right? So just be careful for the sign, right? Positive and negative. Be careful, right? We have minus into minus like this. We have minus into minus. Be careful when you calculate. Okay. Many students make mistake on this. Okay. In fact, this is for more specifically, we put blanket here. It's maybe better, right? It's become minus. It's become IA minus VA divided by R1. Then minus VA divided by R2 and plus VB divided by R2 equals 0. Like this, right? Okay? Should be like this, right? In fact, here. When you solve the equation. Okay. Then we just substitute the known value and then rearrange it and then solve for VA. We will get VA at 1.667. We get VB at 2 volt here, right? By solving these two equation and two unknown, right? Okay. So if we have the circuit with three nodes, we can get two equation, two unknown. Okay, by making one node as reference. Okay. Okay, I think I can skip this equation. Okay. No? What is your question? No? Okay. So I can skip this example. You can try to substitute the known value and solve, okay? And solve the equation. Then you get, finally, the final equation to solve should be like this, right? Okay? Should be like this. And then you solve for VA and VB, right? So I think I don't need to solve linear equation for you, right? Otherwise you will be boring, right? It's boring for you. Then next, to analyze the node analysis, right? To apply the node analysis in the circuit with voltage source, right? If we have the voltage source in the circuit, if that branch have the voltage source, we get VA directly. VA will be VS. Then we just follow the step. Okay, we just substitute that voltage. Okay. But sometimes it make the circuit more complicated, a bit more complicated. Okay. Yeah. In this circuit, we just know VA directly, so we can solve it. Uh, you can easier to solve here. Okay. For example, if we uh, need to solve this circuit, right? We take KCL. So for VB and VC is enough. And this is VA is will be VS. Yeah. If we apply KCL here, what happens? The current flow here is VA minus VB divided by R1, right? And then the current flow here is VB divided by R2. Okay, and we consider the current flow here is will be VB minus VC divided by R3, right? And VA is VS, right? We just substitute VS here, right? Just like this, just substitute the voltage that we know, right? We know. At node C, then VB minus VC, right? VB minus VC divided by R3, and for this VC divided by R4, and is plus is. So we have these two values, and we solve for VB and VC as unknown, right? VB and VC as unknown. This is two equation, two unknown. Okay, and here the author arrange the equation to this form for you. Really mean two unknown, two unknown, two unknown. Okay. Okay, now let's see some example. Okay. Use node analysis to determine the current I. To solve for current I. Okay. To solve for current I, then that flow to the voltage source in the circuit. The figure 3.11 circuit. So R1 is 2 ohm here. Oh, so R1 is 2 ohm. Okay. R2 also 2 ohm, right? R3 is 4 ohm. R4 is 3 ohm. Right? I, this is 2 ampere. And V is 3 volt. And to solve for I, right? But using node analysis, this is the command, right? If the program state that use node analysis, but you don't use node analysis, but your answer may be correct. So how can you get the score? So if the question state that use node analysis, then you use mesh analysis or you use any method, right? If the question say that any method to solve for I, okay, it's up to you. Okay, in this case, you need to use node analysis, right? Okay, so we use node analysis because we are learning node analysis, right? Okay, then apply KCL. So we have this node V1 and V2. Okay, in this case, we have voltage, voltage source here. Then V3, VT will be written, will be filed later. Okay, VT. Because VT and V2, the difference between V3 and V2 is 3 volt. We know, right? We know different. If we know V2, then we know V3. Or if we know V3, we know V2 also. Because V3 minus V2 is 3 volt, right? We can substitute VT by V2 plus 3 volt, right? Or we can substitute V3 by V2 by VT minus 3 volt. Okay, we don't need to solve 3 nodes, right? In this case. Then when the circuit have voltage source, the nodal analysis will reduce some unknown. Okay. Yeah. Okay. So we take node 1 and node 2 KCL. For node 1, first V1 and V3 current flow, sorry, V3 minus V1. So they consider this direction and this direction, right? This direction and this direction. So any direction is will come out with the same equation at the final, right? V3 minus V1 divided by R1, this current, right? This current. V2 minus V1 divided by R2, this is the current, minus I, okay? If I consider the current in this direction, it's not wrong, okay? But the equation become V1 minus V3 divided by R1, right? Minus here, right? It's become minus, right? Minus, and minus V1 minus V2 divided by R2, and then minus I equal to 0. Are they same equation? Are these two equations are the same, right? Right? It's the same equation, right? Okay, so we can consider any direction, right? But do not do the wrong calculation. Okay, keep the direction and the sign in corresponding in according to the sign. Okay, so you don't need to worry the current flow in or flow out. Which one we use at a higher voltage is up to you. Okay, right? On the other hand, if I consider the current flowing out in positive, I will get this equation, right? Because flow out is positive, V1 minus V3 divided by R1. V1 minus V2 is positive, V1 minus V2 divided by R. I flowing out is positive. So this is also the same equation, right? Okay. So just keep consistently when you write the equation. So it's up to you. It's depend on you. Convenient to do. Just do not use flow out positive. Then this will flow out negative. Flow out in flow out in is negative. If you mix together, you get the wrong equation. Okay, finally you get the wrong answer. Okay, so again, I found many students do something like that, right? Not keep consistently in the calculation. Okay, then we have KCL node 1 and we have KCL node 2 here. KCL node 2 is I minus I here. And then V1 minus V2 divided by R2 and minus V2 divided by R3, right? This here is node 2 equation. Or we can substitute I by KCL at this node, right? Here we I okay minus the current flow here and the current flow here, right? V3 minus V1 divided by R1 minus V3 divided by R4 equal to 0, right? Then we get this equation. Okay, it's okay. And we substitute I. Okay, I. This is I, the current I. And we get, if we substitute I value, we get this form, right? Finally, the equation of node 1 and with substitute known value and node 2 with substitute known value, we have two equation, two unknown again, right? Oh, sorry. V3 is firstly we have V3 in the equation, right? And then we substitute V3 by V2 plus 3 volt. V3 is V2 plus 3 volt, right? As I said, the difference between V3 and V2 is 3 volt, so we can use this relation, and we substitute V2 plus VT into V3 here. We just substitute here. We rearrange the equation again. We get two equation, two unknown, right? Two equation, two unknown. Then we solve for V1 and V2. After that, if we know V2, we will get V3, right? If we know V2, we will get V3. Okay. Then after that, we can solve for I, right? By this equation. Finally, we solve for I, right? By this method. So if you have constant voltage source, you have voltage source in the circuit, it's more difficult to solve by nodal analysis. Okay, because this you need to get some relation between two nodes like this, right? Okay, an equation. Maybe you can follow. I think you can follow, but you need to refresh again. Okay? This if is very good if you can read again today. If you leave it for one day, maybe it's harder to remind. 2 days, hard. 1 week. What happens if you just leave it for 1 week and you come back to see it? Okay, just almost empty knowledge, right? So tonight is very good time, right, for the course that you study today. Okay, just uh, take some 30 minutes or 1 hour, just maybe just 1 hour to remind again everything that you learned today. Okay, it's a good practice. Then you don't need to study hard during final, right? During the end of the during examination period, it's better. No question. Okay, so you can arrange the equation with your skill. Maybe you familiar with some answer equation. Just follow this step, right? Okay, equation is okay. On the other hand, I can use. We have to define current I. Yeah, current I, right? Unknown, right? It's maybe we arrange three equation first, right? Maybe three equation. Then we reduce the current I later. It's up to you. There's many way to solve this type of circuit. Right? This is the final solution. Okay, I will stop my record here.